It's an honor to present our speaker today, Rachel Kaufman. She is a full-stack software engineer working in the martech space. She loves writing unit tests, strongly typed languages, and the Oxford Comma. She is also a lead organizer with Women and Gender Expansive Coders DC, a group for women and non-binary people in tech in the Washington, DC area. Rachel, we are really excited about the session with you. The floor is yours.
Thank you so much for that introduction. I really appreciate it. I'm going to try to share my screen here, and I think we are looking at it. Okay, great. I'm so honored to be here. Thank you, Frontend Queens, for inviting me. My name is Rachel Kaufman, and we are going to be talking about animating in React without any libraries and getting really good 60 frames a second performance. And spies may be involved, as you can tell by this screen here. So this is a project that when I first thought about doing it and was told what to do, I was pretty sure it couldn't be done because React is designed to render pretty fast, but not really that fast. So then I told some other people about what I was going to do, and they also told me it couldn't be done. And then we went ahead and did it anyway, and I'm pretty happy with how it turned out. First things first, grab the source code, scan this QR code. This will take you to a repo where you can get a copy of these slides. You can get the demo code that we're going to be playing around with, and there are links to a few more resources. And I will show this QR code again if you missed it, or you can grab it from the recording. All right, so today, here's our mission. We're going to animate stuff. We're not going to give up the convenience of React. We're going to hopefully make it look pretty good. Yeah, that's the mission. And you might be thinking, well, we can already do this with CSS. CSS animations are amazing. They're very performant. You can do all kinds of stuff with them. Here's a very, very basic example of this pulsing button. You can Google easily and find incredible, like mind-blowing CSS animations done in pure CSS. But the thing that all those animations have in common is that you kind of know what they're going to do ahead of time, you as a developer. Something is size X and becoming size Y. It is in position X and moving to position Y, opacity X to opacity Y, that kind of thing. And as you can see from this GIF, what we actually need to do is animate real-time data streaming from a backend server, completely unpredictable, and we don't know what it's going to do. All right, so I'm going to give you a little context. This is about me. As you heard in the intro, I am a full stack engineer and I work at a martech company by day. By night, I'm a secret agent or just a regular freelancer, I guess. I occasionally pick up some work. And that's why I experiment with crazy ideas like this. So I got this request from a client. The client was making a museum interactive for a museum in Washington, D.C. called the International Spy Museum. It's a real museum run by actual former spies, and they have all sorts of great exhibits on spycraft. And this client was going to be running or creating a interactive for a new exhibit that would teach children and museum visitors about facial recognition, how it works, how to defeat it, why and how it's flawed, that kind of thing. And that client came to me and wanted the front end to be built in React for reasons we'll get into. And I said, absolutely, I totally want to do this. I really want to be involved. That client was my husband, so I kind of couldn't say no, but I did really want to be involved in this project. So that's me. And let's talk about you. You will get the most out of this talk if you're already somewhat comfortable with React. This is not a React 101 talk, but on the other hand, it's not super advanced React. We're just putting things together in ways that might be new to you. They were certainly new to me. Also, it will help if you have heard the word animate before, but this is not an animation talk. You don't have to know anything about animation. I'm not going to say the word tweening. I'm not going to say keyframes. I'm not going to say onion skinning. I didn't even know what that was. I had to look that up. The most complicated we're going to get today is like connect the dots. So if you can follow along with that, you'll be fine. So I think a video would explain what this product was pretty well. Essentially, there's 3 cameras here, and they're looking for visitors in the museum. And if they see a face, they're going to animate those sort of spy CSI lines that you saw in the animation onto it. And then there's all this other interaction. So you can tap on your own face and get a match to see what celebrity you look the most like. You You will sort of see these lines blitting in and out a little bit. That jitter, unfortunately, we found out that it was coming from the back end, basically due to a bunch of trade-offs we had to make. The back end can go a lot faster, but in terms of the balance between how many faces do we want to be looking at the same time. Notice it's really dark in the museum. This is how light it is at a normal time. Basically, we had to make some trade-offs, but so you'll see how this works. There's the animation. This part is pre-rendered. I was so pumped, by the way, to have been matched with Admiral Hopper. That had never happened in our testing. It was really kind of an honor to be a woman coder. I did not, set this up. It actually happened for real. Okay, so let's look at some of the architecture because again, I think that will explain why React. So we got the three cameras. Again, there are three cameras. We wanted to have different heights because if you're a tall adult or a short child or a wheelchair user, we want people to be able to participate. So there's three cameras. So now then there's a backend that is using real-time analysis to identify faces that are in these video feeds using custom Python code written by my husband. By the way, really important, this is entirely local. The face data, video data is not uploaded to any cloud service. It's not stored anywhere. It just stays on the machine. I want to be really clear about that, especially because there are kids, participating with this. It's very, very secure. So we've got the three cameras, we've got the backend. The backend is going to decide which of the three cameras is the quote unquote best camera. They're determined by most faces, most clearly visible. We then tell the front end to render that video stream, but the front end is already looking at all three video streams and just choosing which one to render based on the signal. And then we animate the face geometries back onto the video. That's the technical challenge that most of this talk will be about. Then you saw, person clicks on their face, they tap match, there's a modal that pops up, we show the video, we compare with the database of public figures. Also, our database of public figures is like less than 1,000 people, which really helps with getting across the idea that facial recognition can be flawed, which is one of the things that we wanted to talk about. It's really only as good as it inputs, right? The algorithm has never, ever said that I look like Audrey Hepburn. People really hate when they get this one. This guy's in here. It's not flattering to be told that you look like Henry VIII. But anyway, so you've got all these modals. Some you didn't see in the video include a pause button so that people can take selfies with their face. There's a credit modal so that you can see, the image credits. There's a secret guest services menu so that museum staff can restart the computer without having to unlock the whole case, the whole thing. There's timers so that if someone like leaves it open and then walks away, the app doesn't get stuck in a weird place. And like none of this stuff is rocket science, but like I didn't want to do all that in vanilla JS. I recognize that there's a general movement away from frameworks when possible, but like this is kind of what React was built for, right? And yet people said this should not be built in React, which is fair. At a high level, you've got the virtual DOM. Every time something changes, React is diffing and comparing and deciding what to re-render. And that's not really fast enough for 60 times a second. Also, if there was a library that would handle all this for me, obviously I would just do that, plug and play, grab and go. But as far as I can tell, there isn't such a thing that is flexible enough for this use case. But like I said, still wanted to use React. So my reason for using React, I already said, I'm naturally lazy. And when I thought of all of the states that the app could be in, I really wanted to use something that was built for managing complex state. Secondly, and this was my husband's reason, we could have just done this in like Pygame or Touch Designer. It doesn't even have to be a website, right? This is just a touch screen in a museum. But in modern browsers, you do get free GPU acceleration. It's just automatic. And I do think that we did get a little bit of performance boost there. And then finally, I'm a web designer. I know React. Sometimes you just reach for the tools that are at hand. And so would I recommend learning React just to force it to be an animation engine? Absolutely not. But if you already know React, you might as well be able to make it do silly things like this. So to sum up, this might work for you if you have a complex UI of which only a small part of it is the animation, and you want to manage that UI with React, and then the animation isn't really predictable, so you can't do it with CSS, you might be able to use these techniques. So how do we do it? I'm going to try to distill my thoughts down to 3 or 4 major points. I'll be the first to admit none of these tips by themselves are really groundbreaking, but I didn't really see anyone putting these together in exactly this way, so maybe you'll see something. So first, how do you get the data from the backend to the front end as in a performant a way as possible? We're going to use WebSockets. What's the most efficient way to actually animate is going to be requestAnimationFrame. And then what's the fastest way to render the animation onto the canvas or onto the screen? We'll use a canvas. And then finally, we'll use debugging tips for when it doesn't work on the first try. Before we do that, I do want to show you the sandbox that I'll be using for some of these demos. Again, this is the same QR code as before. You can get this on GitHub. I'll show it again later, but take a look at this. So this is a incredibly stripped down version of what you just saw. There's no matching, there's no video, there's not even a backend in this case. This is connected to a mock service worker that is spewing some semi-randomized data to the front end. The way that it's set up is after each frame renders, we just make a request back to the mock service worker and say, give us a new frame, and then it randomizes the face and sends something to the frame. So it's a little alarming to look at, like it's just kind of uncomfortable, but facial recognition is alarming, so that's okay. And this is the code that we're going to be covering today. It's kind of a lot, but it's also only roughly 100 lines, and like most of it's boilerplate. So we're going to start from nothing and build up to this. And by the end of the talk, you'll be able to understand every line here. All right, so first things first, WebSockets. So this is not strictly a requirement for React animation. I think it is a requirement if you're animating with data from a backend. So for example, you could render this really cool cursor matrix falling rain thing, and you could animate this in React. And in this case, the data is still randomized and unpredictable, but it's using the user's mouse cursor as the data. So you don't need a WebSocket connection. You don't need any connection for this. But I'm going to assume that if you're using camera data or stock market data or weather data or anything that comes from maybe a backend, you probably want a WebSocket. So these are just a way to open a connection once and persist that connection. So instead of making a new REST request to get the most updated data, you can just get real-time updates through the existing connection. You don't have to connect to the server again. You just say, hey, give me a new one. It's really fast. It reduces the amount of overhead because you're not sending headers every single time. And you don't really have to work that hard at it. Like really just use a library. It's very easy. So that's the best part. Here's a really rough, probably oversimplified diagram of how it works. But basically, if you've got a client talking to a server, instead of having to make a new request every time, you can just sort of stream data from the backend. And there are also two-way WebSockets. Now, I will say there is a trick with the libraries. There is a really popular one on GitHub, and it has over 1,000 stars. And unfortunately, it's got a little bit of a bug in its internals that does not make it usable for anything where you're trying to prevent React from re-rendering. If you're trying to do something fast, you cannot use React Use WebSocket. React Use WebSocket Lite is a fork of that library. It's less than 6 months old. It has exactly 17 stars last I checked, but it works really, really great. So if you are planning on doing anything with WebSockets and animation, you definitely want to use the Lite one. That's all I have to say about WebSockets. So we're going to talk about animating, and I'm actually going to skip ahead to requestAnimationFrame, and then we'll go back to HTML canvas. So if you're writing JavaScript and you want something to happen on a certain interval, say 30 times a second or 60 times a second, you might naturally think, oh, I'm going to use setInterval because it's right in the name. This is not actually the best way to go, so we're going to use requestAnimationFrame instead. setInterval has a few problems with it because mostly the problem is when you get down to milliseconds, the interval refresh rate is more of a suggestion than a exact thing. So it might refresh 15 milliseconds, 17 milliseconds. It might not, it's not guaranteed to hit it exactly 16, which is 1,000 divided by 60. If your animation loop takes longer than 16 milliseconds, because like it's really complex, it might sort of stack up or jitter. And also, it used to be true that setInterval would just keep running in an inactive tab, which would just eat up your user's CPU and memory. This is no longer the case in modern browsers, thankfully, but it's still something to be aware of. Now, instead, we've got something called requestAnimationFrame. This is a standard JavaScript method. It's been around for over a decade, and it's synced to the client's display refresh rate. So it knows exactly when the browser is going to execute a repaint and does its work then. And it is guaranteed to slow down or stop completely in an inactive tab. So it will save your user's CPU and memory. The syntax is a little stranger if you're not used to it. Basically, on line 5, we kick off a request animation loop with a function as the parameter, and the callback draw then calls request animation frame with itself as the parameter. Now with React, we do need to take a few extra steps. I have simply wrapped my whole request animation frame loop in a useEffect hook with no dependency array. Now that means that it will fire once when the component mounts. Again, we've got our draw function from lines 3 to 6, and then we just call request animation frame with the draw as the callback. But on line 8 through 10, we have to take advantage of the useEffect cleanup function to cancel the animation frame. Otherwise, it will sort of run forever and you might get a memory leak. Now, of course, I've been cheating here because on line 4, it just says animation logic here. That's not that interesting. What actually goes there? So this is where we're going to scoop back to drawing the data, and we're going to use HTML Canvas. Now, many of you have probably used Canvas. It's a very old browser API. It's been around since 2015, and it lets us draw simple shapes, lines. We can even render bitmaps. It's automatically hardware accelerated if and when the end browser decides that that's possible and necessary, and it is the backbone of drawing on the internet. It's used in all kinds of popular libraries like Phaser.js for video games, P5.js for creative coding. Even Figma uses it under the hood with some very cool optimizations to make it really, really fast. Basically, it's everywhere, and we're going to use it today. All right, so, excuse me, there we go. Also, Canvas and WebGPU are a pathway to many abilities that many front-end devs consider to be unnatural. I don't know who this Redditor is, but I believe they are correct. Okay, really quick point of order. I've been saying render a lot, and I'm about to say render more. This might be the one animation term that I'm accidentally saying because it means two different things. So render in the animation sense, this is not Merriam-Webster, this is my definition, means put lines or something onto a screen to create an animation. Render in the React sense means put that component into the DOM for the first time or update that component. You could also hear mount and re-render or mount and render, but basically the way we get the most performance when animating in and around React is to render in the animation sense as much as possible and in the React sense as little as possible. We don't want unnecessary re-renders. All right, so also to inject a canvas into React, we are going to take a few extra steps, and the first is to use a ref. Now, this is where the purists might say I'm not actually animating in React, right? I'm animating outside of React by using a ref. I think most people have used refs, but briefly, they are an escape hatch that give you direct access to the DOM elements that React manages. They're typically used for things like setting focus, scrolling to a specific view, and we're going to use it to draw on our canvas element. So at a very high level, our canvas component here would wrap a raw HTML canvas element. We give it a ref property so that we can call the useRef hook on it. And then we just use an effect to grab the canvas's context, which is just a property of the canvas element. And we store that in state so that we can access it later. Pretty simple. So how do we actually draw on a canvas? So again, there's lots of methods you can use if you have access to context, circles, lines, etc. We're just going to use lines. So assume that we have a list of XY points, like on line 1. First thing, in each frame, we would clear the drawing away. So clearing from 0, 0 to whatever the size of the canvas is. And then we just need to draw a line from each point. So we start a path, and then we iterate through the list. And it's essentially just connect the dots. And at the end, we can apply a stroke. That's basically it. So if we had a single frame, and this is just back to vanilla JS so we can look at it, we could render points to the canvas this way. Again, we've got our list of points. In this case, I'm applying a style to the stroke. And then we begin the path, we tell it to go somewhere, and then we just draw a line from each point and apply a stroke. And if I were to do that, I get a triangle. Very cool. And so if we want to animate it, we can bring in the request animation frame from earlier. We've got our canvas, we've got our animation frame ID, and then we've got a draw loop where we clear the canvas. In this case, I'm using math.random to slightly shift the points around, draw a line, apply a stroke, and then loop through again. And if I were to start it, we have kind of a wiggly triangle. Kind of a flat triangle, but that's the problem with using math.random is that you don't really know what you're going to get. So, got a triangle there. So, one performance tip here that didn't end up working for our use case, but can be a good one to get more oomph out of canvas. Notice here how on line 4, I'm clearing the whole canvas, or just trust me that the canvas here is 300 by 300. So we're clearing a rectangle starting at 0, 0 and 300, 300. That's the whole canvas. If you're animating something where you know that only a small chunk of it has changed, keep track of the part that changed and only clear that so you don't have to redraw everything. You just have to redraw the delta. This ended up not being useful for us just based on like how people move through the space and how the faces were animated, but it can definitely get you more performance in other situations. So now we just have to take this vanilla animation, this wiggly triangle, and make it into React. So this is, better stop that. This is the last code example, and it's also the longest code example. But it's just everything we've already seen. And again, this is all on GitHub, so feel free to look in it in more depth there. First of all, just like before, everything's inside a useEffect hook. Hopefully it's going to fire only once when the component mounts. The dependencies, there are actually dependencies here, but they're things I don't expect to change much at all. I'm keeping it in this hook anyway, because I still need to use the cancel animation frame later. So inside the useEffect, we've got our draw function, which is very similar to what we saw in the previous slides. The difference here is that our face data is in a variable that I called facesRef, because I'm actually storing the data in a ref, which means it persists across renders, but doesn't cause React to re-render. Some folks might not be familiar with this use of the useRef hook. I certainly wasn't. I mostly use it for connecting to the DOM. I do have a blog post about this with more information that is linked from the repo. So if you scan that QR code, you can go and learn more about it. But that's the short summary, right? We've got this variable data that can change, but we want it to persist across renders, but we don't want to cause the component itself to re-render. Okay, so then we've got our request animation frame cycle. First, we've got check for the value here, clear, begin path, iterate through the points, apply a stroke. Here's a request animation frame cycle. I've got a function called render request new frame that executes the draw loop, sends a message to the backend saying, give us the next frame. Again, it's configured to just send the next frame anytime it gets a message from the front end. And then request the animation frame again. And then we clean everything up here. The only code you're not seeing in this snippet is how we process the webhook data to put it back into facesRef, but it's really just JSON parsing. It's very easy. So I'm going to just switch to here so we can just see the same thing. This will be important later, but here we are initializing some variables. Here's the JSON parsing that I mentioned. Basically, just get the message from the webhook. This is just some boilerplate to configure our webhook. And then here's the same thing we just saw with slightly more stuff in it. The difference here is that because we have 9 face body parts, I think, left eyebrow, right eyebrow, left eye, right A, etc. It's actually a list of lists or an object of lists. Or I'm not going to get too deep into the weeds with the specific implementation details of how to animate the exact face, but it's pretty much the same code. We clear the rectangle, we loop through each point to connect the dots, and all of this happens in the context of request animation frame happening every 16 milliseconds. So that's that. Now, there is one last thing we need to do in order to make sure that we are not unnecessarily re-rendering our canvas component, which would force React to be doing more work than necessary. Surprise, we're going to prevent re-renders and get some better performance. So first we got to memoize it. Now, React Memo is, I think, an underutilized feature of React, not to be confused with the use memo hook. It's similar but different. So without React Memo, when the parent component re-renders, the child will re-render. You don't necessarily want that. Maybe you only want the children to re-render when its props change. So that's what Memo does. React is going to do shallow prop comparison and decide whether or not to re-render that child component. In our case, the parent state is changing a lot. It's getting different information from the backend about like what camera to use. It's getting information about like what modals are open. We don't necessarily need to re-render that child canvas every single time. However, this sounds really, really good. By the way, this is the replacement for component should update back from class components, if anyone remembers those. This is the functional version. But yeah, if React now has to calculate whether or not to re-render a component, that can actually be more expensive than just re-rendering the component, which is why it is not by default. That said, if you're using React 19 or higher, React compiler you can install, and allegedly it will handle memoization intelligently for you. We did not use this on this project because honestly, I didn't know about it. But I would be surprised if this section was not obsolete in a few years. If it works, great. I'm really looking forward to seeing what it can do. I'm going to show a demo of that real quick. So this is where our console log comes into play. So you see I log when this canvas renders, we get a log. So let's inspect, excuse me. All right. All right. So we've got actually it renders because the canvas, or excuse me, the webhook is turned on. So we did get 2 renders here, but that's pretty good. Now, if I were to force this parent to re-render, you can see that this irrelevant value in the parent component is changing, but nothing is happening over here. If I switch over to React Memo, now this looks pretty much exactly the same. It's now logging I have rendered sad face. And if I change this irrelevant value, every time I do that, this counter goes up. Now, you're not seeing a performance hit to this animation every time I do this, because this is a toy demo app, but it absolutely does make a difference in production, I can assure you. Using Memo is really, really easy, as you can see from this. Again, it's so easy, you would be tempted to use it everywhere, but it's not necessarily worth it if the prop comparison ends up being more expensive than just a re-render. But it definitely works for something like this. All right. Work with, not against JavaScript. So I'll be honest with you, I almost never think about the time and space complexity of built-in JavaScript methods because I just don't work with like really large data sets. But in this case, we did find that for each was slow enough compared to other loop methods that it made a difference. Some people say that the for each item syntax can be twice as slow as for item of blank. I tried to run my own benchmark on my computer to test that, and it actually just crashed when using for each. So I think I need a new computer, but I can confirm that for some operations on a big array, you are better off using a different loop method. So there's that. Okay, so how do we debug all this? This is what we're going to do. Chrome's dev tools are the first place you're going to want to go, specifically the memory tab. I had really good luck using this allocations and timeline view. I am not a web performance expert. I cannot tell you all the secrets of using this panel. But what I can tell you is that I would go here and I would let the app run and hit record. And eventually I would hit stop and I would get something that looked kind of like this. And I was looking for 2 very, very basic things. First of all, I was looking for references to Fiber. Fiber is React's internal reconciliation engine. So if you see a lot of Fiber, it means React is rendering a lot. And again, we're trying to prevent that. And then secondly, I was looking for a memory leak. So if this bar here eventually goes up instead of staying relatively stable, we know we have a problem. There's a lot more sophisticated things you can do here, but if you're new to this world like I was, those two things will get you pretty far. Next, Chrome has a FPS meter, which is kind of amazing. I didn't know about that until I was working on this project. So here's an animation of it, but I'm actually going to show you how it works in real time. So if you have your DevTools open and you press Command-Shift-P, you get a menu that pops up like this, very similar to the like VS Code command palette. And you can find there's so much stuff here, but I just typed FPS, and you get a little memo, a little meter here. And so this is showing us that we're getting 60 frames a second and that our GPU acceleration is on and that we have plenty of memory. And so if I were actually to go back to here, we can see that our frames per second are pretty stable. Oops, excuse me. Here we go. And if I switch, this is actually interesting because I think it's actually saying that the animation is smooth, but we're now specifically hitting times in the repaint cycle. Again, you're not going to see a difference with setInterval in performance in this toy app, but you can play around with it differently and like see how things change when you render components. I think it's really cool. I'm just going to turn it off. There we go. I think that's really cool. Finally, it's kind of a joke that front-end developers debug with console logs everywhere, but you know what? They work, right? So sometimes they're useful. And console time and time end are like the weird cousins of console log. So if you call console.time and give it a string name, and then you do something, and then you call time end with the same string, you will get an exact timer of how long that operation took, which is just really, really useful for finding out if your animation loop is slow or if there's something else that's slow. It's really, really great. So that's it. We've mission accomplished. We have learned one set of tools for animating within React. You know what? This is one way of doing things, and it's what worked for us. And I would not be surprised if there were other ways. So I hope you learned something. But basically now the client is happy. We're happy. Museum visitors are happy, even if they're being tracked by a creepy internal facial recognition algorithm. And so I hope that you can put some of these tips into practice. And once again, please download the slides and source code, or feel free to reach out. So that's it. And I guess we'll turn it over to questions if there are any. And if there aren't, that's okay too.
Thank you. Great session, Rachel. It's really interesting to see how you built this face recognition app without using some fancy algorithms, but and everything is stored on the device, which is great.
Yeah, that's true. I mean, we should do a second presentation about the Python code that powers this. But my mission was really just to take the data that already existed and render it onto the screen and hopefully make it not jittery. And I think we did a pretty good job with that.
Yeah, it was really interesting to see behind the scenes how you did this because it's really interesting um, project, and I'm sure that you learned a lot while working on it.
I hope that you learned as well. I see that someone has got a raised hand. Do you want, should I be calling on them or do you want to do it?
Yeah.
Hi, hi, my
Hi,
name
Hi,
is
Julia.
Julia.
Hi, Julia.
Hi. Yeah, just wanted to, I was very curious. So what language did you use in the backend?
Right. So it's Python, which compiles, it's C, Python that compiles down to C, which makes it more efficient. And I don't know a ton about it, but I believe that dlib was what was used.
Okay. So did you work with do you have already have a model generated, or do you have to create by yourself?
That is a question that I'm afraid I cannot answer because I didn't work on the back end at all. So my responsibility was receiving a big JSON blob from the back end through the WebSocket and doing stuff with it. But I will pass on the feedback that folks are really interested in the local models as well.
If anyone also have question, can raise a hand or drop it in the chat.
Thank you, Julia, for the great question. Rachel, the session was amazing and very deep diving. I love the insights you share, and your slides are actually amazing as well.
Thank you very much. This was a real pleasure. And
Yes.
please download the source code and play around with it and let me know what you think.
Yes, everybody is very excited and thankful for the session. We don't have more questions. If you want to rewatch the session, it's going to be available in the next 2 weeks in our YouTube channel. And Rachel, for us was an honor to have you. I hope we're going to see you again.
I absolutely will see me again. Thank you so much.
Thank you.
All right, take care.
Thank you.